Namaskar, welcome to Prakash and Basics. I am Prakash Zog and we are talking about one of our most important faculties, vision. If you apply for any particular job, a government job specifically, or an entrance exam to NDA or some other examinations of this sort, police department and so forth, you are expected to go through a medical examination. And then in this process there is also a test for your eyes. The most common eye test is placing you at a particular distance from a chart and asking you to read, starting from the top and going downwards, one eye at a time. Usually starting with a right eye, so you cover your left, read using your right eye, and then cover your right eye and read with the left. And next to the alphabets there are some numbers that are written, and as you go downwards from first line to the second to the third to the fourth, the size of the alphabets becomes smaller and smaller and smaller and smaller, and you come to a point where you cannot read the lower line any further, and then the number to the previous line where you can read is noted down, and then you start over with the second eye. And once this is over, the person who notes down tells you or talks in terms of either 6 by 6 or 20 by 20. And if you visit an ophthalmologist or a eye doctor, then among the tests that he carries out, this is among the first tests that he would also do, and tell you that your vision is either 6 by 5 or 6 by 4 or 20 by 40 or 20 by 90 or 80 or 70 or some number of this sort. If you are talking in MKS, that is the metric system, and if the distance is measured in terms of meters, then you talk in terms of 6 by 6 or a smaller set of numbers. And if the basic distance is 20 feet, or if you are talking in feet, then your vision is measured in terms of 20 by 20 and so forth. Let us try and understand what all this is today. Let us first understand the basics and then go into a bit more of the scientific or the mathematical detail about this, because that's what every intelligent person must also know. We'll first talk of distant vision. That means when you are trying to look at things that are far away. The process I have already told you what you do. What you are actually doing in this process is undergoing a test which compares your vision with that of an average person. At what distance can you see clearly, minutely, accurately the details of the alphabets that are there, identify its sharp edges, and also naturally identify the letter itself? As you go lower and lower down, it would get more and more difficult, and that's what would happen. So when I am talking of a number such as 6 by 6 or 20 by 20, then suppose there is a normal person standing at 6 meters and looking at a particular alphabet and seeing it clearly, and if you are also standing at 6 meters and seeing the same alphabet clearly, then your vision is said to be 6 by 6. Here of course this is in meters, and if it is measured in feet, it will be 20 by 20. Let me clarify that this is a ratio, so it's just a number or a fraction, that's all. Also, this is in comparison with an average person. you can see something very clearly at 6 meters, and an average person must have to bring that to 5 meters or 4 meters, then your vision is said to be 6 by 5 or 6 by 4, and the number is obviously greater than 1, and you are said to have better vision than an average person. On the other hand, if you can see a particular set of words clearly at 6 meters, or rather 9 meters, and an ordinary normal human being can see it clearly at 6 meters, then your vision is said to be 6 by 9. If this is the pattern by which numbers are measured, then you again get a ratio which is referred to in terms of 6 by 9 or 6 by 12, or it could be 20 by 40 and so forth. So this is the pattern by which these numbers are talked of. For better vision, the ratio has to be greater than 1, and for a poor vision, lower than the average, the ratio is less than 1, or it is a fraction. For normal human population that is around, the values vary between 6 by 4 to 6 by 7.5, and that's the range of people that are around. I am presently talking of large distances. So let's begin by discussing that area to a greater extent first. As I said, it is a chart that is placed, and this chart is known as Snellen chart. It was developed by a Dutch doctor, 1862. That's the time he put forward this concept. It actually consists of 11 different lines. It has to be read from a distance of 20 feet or 6 meters. 11 lines. The topmost line has only one alphabet, the second one 2, the third one 3, the fourth one 4, and you go down till you come to the 11th line with 11 alphabets. Next to each of these alphabets there is a ratio that is specified. The size, as I told you, keeps on going down, smaller and smaller and smaller and smaller, and 99.999% the chart is black and white. Or if you are in a medical center or some place of this sort, it could be black on a illuminated sheet which might be slightly yellowish. Not everywhere can you have a distance of 6 meters straight ahead. So what happens in a particular doctor's room or an ophthalmologist's room is that the distance is 3 meters. Above your head here is the unit in which the letter is being projected or the chart is being projected, but it is inverted, and in front of you there is a mirror, and you are seeing the reflection of this chart in the mirror. So it's 3 meters and 3 meters, making it a total of 6 meters, and that's how it is adjusted. If by chance the distances are different, the chart size is modified accordingly. Now you don't really put your hands in front of the doctor, so there is a set of goggles that are given with open spaces and an occluder or just an opaque plate is put in front, so that you can't see with this eye, you can see only with this eye, and you go ahead with the testing. You do it with the right first and then with the left. The alphabets are invariably in English. The most common type of charts have these, and the numbers that are written are the topmost line has 20 by 200. The eighth line is 20 by 20 and the lowermost line is 20 by 10. If I'll repeat the definition, the original one, and that is that at 6 meters or 20 feet, the line that an average person can read is the same as the line that you are capable of reading, then your vision is said to be 6 by 6 in terms of meters or 20 by 20 in terms of feet. And that, as I told you, is the 8th line. So if you can read below the 8th line, obviously your eyesight is better than the average level. And anything prior to the 8th line means your vision is not all that good. Now, how are these letters designed? You can't just have them randomly. So these are all square sized letters. They are in a grid of 5 by 5. A grid of 5 by 5 in which the height and the width is identical. So the structure is square. And not all alphabets are going to fit into this pattern. So you use only specifically 9 alphabets: A, D, E, F, L, O, P, T and Z. And they are randomly distributed around, starting with a variety of them. Invariably, the top letter is E. Why? I'll clarify as I go into a little more details. The first line, the topmost one, is written with a number 6 by 60 or 20 by 200. You can see that the ratio is 1:10. What it means is that if you are standing at 6 feet, 6 meters and are capable to read that set of first alphabet, the only alphabet, then a normal human being will be able to read that alphabet even if it is at 60 meters. If it is at 20 feet, he could be at 200 meters and still read it. If you can read only that line and can't read anything below it, that means your eyesight is pretty poor. That is obvious. How big is this? On that distance ratio that I talked of, the height of the topmost alphabet is 8.73 centimeters. And by the time you come to the 8th line, which is 20 by 20 or 6 by 6, the size has become 1/10, and that is 8.73 millimeters or 0.873 centimeters. So the size is reduced to 1/10 of what it was in the beginning. There is one more issue in this, and that is how the lines are made. I tried to draw out an alphabet for you, and I am sure you can see this. I am talking of the first line, so you are seeing is E, and as you can see that the ratio is 5 by 5, and the thickness of each of the lines is 1 unit, and from the top line 1, then white line, then black line, then white line, then black line. So 3 black lines, 3 units, and 2 white lines, that makes is 1 more. So a total of 5 units, and correspondingly the horizontal is also the same. The horizontal, and depending upon the alphabet that you are using, you could have different values. I'll come back to this once more later on and clarify what these numbers really signify in terms of maths. During our discussions on the accommodation of the eye, I told you that 6 meters is the distance at which, this is the far point, the distance at which you can see things clearly, and beyond that it doesn't really make much of a change in the eye. So that is why the distance is chosen as 6 meters or correspondingly 20 feet. That is the far point, to see how distance is going to be correlated to your visual ability. As I said, if distance is not available, you use a reflection through a mirror. What are these numbers like? I just mention those numbers. Remember, the numerator is in feet and the denominator will be in feet also. So the first line is going to be 20 by 200, that is the ratio of 1:10, then 20 by 100, then 20 by 70, 20 by 50, 20 by 40, 20 by 30, 20 by 25, and the 8th line then is 20 by 20. If you can read that line, your eyesight is average. But if you can go below that, then the 9th line is 20 by 15 and the 10th line is 20 by 13 and the 11th line is 20 by 10, and 20 by 10 the ratio obviously is 2, and that's the higher end of the performance of individuals. So your ratio, if you are working in MKS system, would turn out to be 6 by 9 or 6 by 18 and so forth. And please remember that it is not essential that both of them will be identical. For many of them, including me for example, the sight or the acuity of the eye would be different for the two eyes, and that number then is specified by the doctor on a card sheet and given to you, saying that this is the number, that this is the acuity of your eye. Realize that this is a ratio, so obviously there are going to be no units to it, and this is in terms of average people. So don't be carried away that if I have 6 by 6 vision, I have very good eyesight. No, it's that average level. Any number that X is on the higher line means your eyesight is bad. Anything lower than this, you are better than average. Everybody can't read English. So naturally there were many other attempts also made. And if it's in Russia, it would be Cyrillic script. In India, we have a Devanagari script. In fact, nowadays charts in all the Indian scripts are available, which can be projected by the doctor on the unit on top. These are all referred to as Sloan's letters. But small children can't read, and so they have a picture chart for children. And there is one more chart that is talked of which fits into all this scheme, and that is to use an alphabet E, but the central leg is extended to the same length. And so even if a person can't read, the chart is talked of in terms of rotating this figure. So the figure is like this, or like this, or like this, or like this, or at an or downwards or upwards and so forth. And so the sequences are mentioned, and when he goes down the line, the person has to just point out that it is like this, and like this, and like this, and like this, and then like this for every line. So he need not be able to read, but still he can communicate and tell you whether what is the level at which he can read. And what's the advantage of this particular chart? It is again back to the E shape. 1 unit, 1 unit, 1 unit, and the gap is 1 unit and 1 unit. So the total is 1, 2, 3, 4 and 5, and the size is again 5 units, and it is then that square letter once more. The Australians developed another mathematical method in which the order is reversed. It is known as a logmar chart, but it's immaterial which chart you read, as long as the ratio of the sizes is matched out. The system is going to work equally well. Now, this is what happens when you are at a long distance, but as I told you, there is also a near point. And if there is a near point, if I have to read something, I have to focus at a close distance. And I told you that there is something known as distance of distinct vision. The distance of 10 inches or 25 centimeters at which the clarity that you can see without straining your eye is the best. And so near vision is tested with a different chart, a special chart with reducing font sizes, and the chart, which is a book actually of different Devanagari script and Tamilian script and other scripts, or Celeric or the Chinese or the Japanese and so forth, and you are supposed to read what is written on each of the lines. Again the size starts decreasing, and these are again like last time numbered, but now there is a prefix of n attached to it, and so it is written as N36, N24, N16, N12, N8, N6. So this is the way in which it is numbered. N6 is the normal vision point which a normal human being would be able to see and read clearly. So this should give us all the idea as to how this testing is done. If it is less fraction than this, then obviously unless it is 1, you need a correction. Your eyes are not good enough and you need to have a correction by using a set of glasses. How that works out is something else that we will talk when we talk of the two different types of defects that we have associated with the eye. But for those who are interested in understanding why that 1-1-1 gap and why that 5/5, no, it is associated one step ahead with trigonometry or geometry if you want. As you are aware, when you look at an object, when the object is far off, the top to bottom or this side to this side, there is a certain angle within which the object fits in and you are able to see it. As the object starts coming closer and closer, that angle starts becoming different, but the ratio of the distance and the size always remains the same. So if things are talked in terms of this angle, then it doesn't really matter at what distance the object is. And this optotype, that means optical typed letter, that is known as an optotype. The smallest optotype letter that can be identified must subtend or hold between its edges an angle of 5 arc minutes. That's the mathematical definition of what it originally is. Let me clarify. That's only for you, for fun, for you to understand. 360 degrees is one circle. So each degree, that means you divide a circle into 360 parts, and each part is then 1 degree. We know that right angle is 90 degrees. That's known to us. So 1 degree is 1/60th, or rather 1/360th of a circle. Now there are a lot of things where the angles are even smaller, so there were fractions made. And if you divide 1 degree into 60 parts, each part is said to be 1 minute. And when you are observing very accurately and so forth, scientifically and so forth, you have to further subdivide this also. And this is also further subdivided again, like hours, minutes and seconds. So the 60, each minute is divided into 60 seconds. But that seconds is a very small angle and is used only when we are talking of stars and so forth. So 1/60th of 1 degree is 1 minute. And if you take the two radii that form the angle, that angle produced and the length of the arc between the two ends is said to have 1 arc minute. 5 such arc minutes is what we are talking of in the definition. And that is why the grid is of the size 5 by 5. And each line has to occupy 1 arc angle. 1 dark, bright, dark, bright, dark. A total of 5, and the size of the alphabet has to be also 5. And if you want to distribute things in this ratio as far as designing that alphabet is concerned, you can't do it for all alphabets. And so it is done specifically for alphabets like E and F and P and D, where there are fixed edges and boundaries that can be marked out, and Z and so forth. That is why those 9 alphabets. And that's going to be valid for other systems also. And that's the way in which the angles are measured. And so when you look at that alphabet, each one then is going to have 1 arc minute subtended at your eye. And if you can, anything that you can distinguish in this particular format is something that has to be measured to decide on whether, in terms of average people, your eyesight is good or bad. Please realize that as the angle increases, the object has obviously to become bigger, or the size of the image on your retina has to increase correspondingly in size. And that's what happens when an object starts moving closer to you. When I take my hand far away or when I get it closer, the angle subtended by my hand at my eye starts changing. And that is why the angle is used as a standard for measurement. 2 or more things before I conclude. If with suitable correcting lenses, the topmost alphabet, single alphabet, that is 6 by 60 or 20 by 200, is not seen clearly even using a lens, then technically you are said to be blind. This problem of not seeing things clearly can start very early. It is known as congenital, that means right from birth onwards. Unluckily, for a child that is just born, it doesn't really know what is good, what is right, what is average and so forth. So whatever it sees, it feels that that is the right. So it is better that the eyesight of a child is tested as early as possible. Nowadays, at the earliest, as soon as the child is born, usually the doctors start checking whether the eyesight is good enough or whether he can see or not and so forth. And if the child complains a little bit also, it is better that the parents take care and ensure that the testing is done. It's not that the lens, you starting to use lens is going to help the child. What's more important is, if this is not corrected very early, then the further development of the eye does not take place. And so the first 3, 4, 5 years in which the eye is developing, in the first 2, 3 months also, where the development is pretty rapid and the movements are being done, there is no motivation for the eye to improve on what it is seeing. and so the eye vision might deteriorate further. So the earlier you do the testing, the better. You must also realize that human body is supposed to ideally peak off and keep going through the phase of anabolism, that is improvement, right up to the age of about 25, 30, 35, and after that things begin to deteriorate. So your eyesight and your vision and your numbers that I am talking of just now are all going to deteriorate and get bad with time, and around 40 onwards people start facing these problems. So you must ensure that proper testing is done, and you should be aware as to what the vision, when you are told that your eyesight is 6/9 or 6/18, how good or how bad it is. If it is 20/40, if it is 20/100 and so forth, and where you need corrections. What type of corrections and how the corrections are made is a separate issue. I'll talk of that sometime later. If you've liked all this, make sure that when you have your cards telling you what your vision is, try and interpret what type of vision you have. Tell your friends about this. Try to learn more about it in more details if you are interested. For more information on our eyesights, we'll meet after 15 days once more and talk of some more issues, because this is one of our greatest tools. Till that time, Namaskar.